I'm Anil Kumar, and in this video I'll take a kind of different approach to write cos of alpha in terms of different cofunction identities. So the question here is write equivalent trigonometric ratios for cos of alpha. So we'll actually consider the coordinate plane, and then let us say that cos of alpha is an acute angle somewhere here, and that is the angle alpha for us. So we are going to write cos of alpha in terms of sine and cosine for different rotational positions. So let us consider first the rotation positions where alpha is added with pi, or if alpha is subtracted with pi, right? Then what happens? So alpha plus pi will bring us to coordinate 3. Is it okay? So that is, this position is alpha plus pi. Now we will apply the cast rule. Now cos of alpha is always positive. Since you are in quadrant 3, cos is going to be negative, and therefore here we should have negative of cosine. So whenever you're doing plus and minus, cos remains cos. The only sign may change. Now let us consider the second position, which is alpha minus pi. If it is alpha minus pi, so that means alpha minus pi, in that case we are actually talking about the position here. Now in this position, cos is again negative, so here again it is going to be minus cos alpha minus pi. I hope that is clear. Now let us look into minus pi. You could have reached like this also. I'm sorry, minus cos of alpha minus pi. That means from here you do minus pi, right? So you come back to this position. Okay. Now let us look into plus pi by 2 and minus pi by 2. That is to say alpha plus pi by 2. So alpha is here, pi by 2 plus will be somewhere there, right? In that case, it turns out to be sine. Now in this quadrant, sine is positive, therefore this sign will be positive. Got it? However, if it was alpha minus pi by 2, that means from here, clockwise rotation by pi by 2, we would have landed in quadrant 4, where sine is negative. So in that case, we'll get minus sine alpha minus pi by 2. Do you get it? So that is how it works. Now let me take more examples, and let's take one where we do alpha plus 3 pi by 2, right? So if you see here, 1 pi by 2, 2 pi by 2, 3 pi by 2, so we are in this position kind of, right? So here sine is negative, and then we'll have sine with negative sign alpha plus 3 pi by 2, right? So alpha plus 3 pi by 2 will actually be this position, and if you do minus 3 pi by 2, then alpha plus 3 pi by 2 will be in this position. Now if I do alpha minus 3 pi by 2, in that case we are going to land where? So this is alpha, so we have to move to 3 pi by 2, so we land in this quadrant at this position, correct? So that is minus 3 pi by 2. Sine is negative here, so it is going to be sine of alpha minus 3 pi by 2. Well, in short, what you have to figure out is that when you do this alpha plus pi or minus pi, in that case cos remains cos. Sine may change. But in case you are doing plus minus pi by 2 or 3 pi by 2, cos becomes sine, and the sign really depends on in which quadrant you are. If you land up in quadrant 4 and 3, then the sign has to be negative. But if you land in quadrant 2, since sign is positive here, you will get positive sign as we got for these two positions, right? I hope you understand and appreciate it. You'll also recall plus pi by 2 and minus 3 pi by 2 is kind of same thing, right? So you land at the same position. Similarly, minus pi by 2 and plus 3 pi by 2 is also bringing you to the same point. So that should also help you to understand and remember these relationships. I hope that helps. Thank you.